Okay, we're looking at LSAT 64. This is October of 2011, Logic Game 3. On the first day of a 2-day study for a cycling magazine, 4 riders, R, S, T, and Y, will each test one of 4 bicycles, F, G, H, and J. Each rider will then test a different one of the bicycles on the second day. Each rider tests only one bicycle per day, and all 4 bicycles are tested each day. Okay, so the first thing that we want to ascertain is whether or not we have any grouping aspects or sequential aspects to this particular game. And we do have a grouping aspect. Basically what we're told is that there are 4 bicycles and there are 4 people testing the bicycles, and each person will test bicycles over 2 days but can't test the same bicycle. So we know that of F, G, H, and J, that 2 people will be testing the bicycles on different days. So those 2 people constitute a group. So we know that we're dealing with a grouping game. The question becomes, is there a sequential aspect to this game? And there's really not. F, G, H, and J don't need to go in any inherent order. The trick to this logic game, however, is to go ahead and create an order with the bicycles. F, G, H, and J, they're alphabetically in an order. We want to think of them like 1 through 4. So the intuitive awkwardness to this game is basically the setup. And the way you want to set up this game is you want to have F, G, H, and J on top, and then 1, 2, 3, 4. On top of these 4 lines is day 1, on bottom is day 2. F, G, H, and J should go on top because if you try to put them on the bottom, each time you build a scenario, it becomes increasingly, you just have to continue writing F, G, H, and J. So once you put them on top, everything is fine, and then you just treat this, again, on top of this is day 1, on bottom is day 2. So let's go ahead and take a look at the rules. The assignment of riders to bicycles is subject to the following conditions. R cannot test F. So we know that R cannot go with F. Y cannot test J. We know that Y can't go with J. Teresa must be one of the testers for H. So T must occur with H. We know that you cannot test the same thing on day 1 and day 2, so I'm just going to put T must occur with H. We know that T has to occur with H either on day 1 or day 2. And then the last rule, the bicycle that Y tests on the first day must be the same, must be tested by S on the second day. So it's really just a block. Y1 equals S2, so it's a vertical block. Okay, as always, we want to utilize the hierarchy of rules to solve the scenarios. And in this particular logic game, we're given these exclusion rules, which I normally don't pay any attention to, but here it's good to pay attention to them. We will put R cannot occur with F up top. Again, we don't want to put it below, because as we build down, we have to continually write it over again. We want to put Y not going with J. So it's up top here. And again, we just keep this vertical look of what can occur. We know that all the way down, R cannot occur with F here. Y cannot occur with J there. So these rules are taken care of. Now we're going to look at the rule with T. So we need to break this up into 2 worlds. T occurs with H on the first day in the first world, and then we just come over and place T on day 2 in the second world, and move this R and Y over. Okay, so we've dealt with T. That's the only thing that can happen with T. Again, we don't know what's happening with T on the second day here or on the first day here, but we do know that T must occur with H on the first day, and it also can occur with H on the second day. So now we just look at what can occur with Y and an S. Okay, so there's 2 possibilities for Y and S, and we just need to break this game out. Okay, we know that Y can't occur in day 4, and we know that we can't put Y in day 3 here because T is there, so that can't work. So Y can only occur on the first day, at least in day 1 and day 2. That's all that Y can do in day 1. and day 2 with regard to t being in the first day. Now the same thing happens with y and s when t is working with h on the second day. And that's all that can happen. Again, we know that y cannot occur here. We can't put y here because s couldn't go there, so we've exhausted everything that could happen with y and s. And we've actually exhausted the entirety of the rules. So now we need to kind of take a look and see what could happen. And the best way to describe this game is it's a chain reaction distribution, meaning that you cannot have, on a vertical basis, 2 of the same variables, and there's very limited things that can happen. So once you start to place variables, then all of a sudden the entire scenario can be solved. So for example, we'll start with this one. We know that R cannot occur here because of this vertical look that we have, so we know that R must occur right here. And then that would mean that S has to go here. Okay, now if we look at this, we know that R cannot occur here because of this vertical. We know that Y can't occur here. We also know that R can't occur here. So that means R would go here. Okay, and then now we're left with the idea that Y cannot occur. So we have Y placed here, and now T. And this scenario is wholly solved, and we're ready to move to this one. With regard to this one, we know that Y can't occur here and R can't occur here. So Y must go here, and R must occur here. Now, if we look at what we've got here, we know that R cannot occur in this spot or this spot, which means that R must occur in spot 3, and then we're just left with an option, which is S and T. Okay, so this scenario is now wholly solved. We've solved half of this, of all the possibilities to the game, and now let's look at this one. Okay, so with regard to this day 2, we know that Y cannot occur here, so it must occur here, and we know that R must occur there. Now, at this point in time, we're kind of stifled. We could continue to open this up. For example, I could put R here and then make another scenario to flesh out the possibilities, but it's really unnecessary in this analytical game. What we need to know is this. I mean, one of the key things that you need to know is at least one day. If you don't have a day, then we should break it out. But because we do, we can just see what's going on here. We have R, S, and T left over. And they can really go in any order other than just this vertical look. You can't have R here and R here, right? You can't have T there. Other than that, it's free to go. The variables are free to go however they need to go. So we're going to leave that one as is. We can see it. It's kind of intuitively solved, so it's unnecessary to go any further with it. Let's look at this one, though. It's a little bit more difficult. We're kind of stifled on this particular scenario. The only thing we can do, we know this. R can go here, and S can go here, or vice versa. So we actually need to break this one apart because we don't have the row. So we'll break this out. Okay, that's all that can happen with regard to day 1 in this first scenario. And then we just need to see if we can fill anything else in on this. Okay, we know that Y cannot occur here. We know that Y and R cannot occur here. If Y and R cannot occur here, that means that T would actually have to occur in this spot, and that would leave an option for R and Y. Okay, with regard to this top one, we're again stifled with this. We're left with R, T, and Y. We just know that Y cannot occur there, and we cannot have this vertical look. Okay, and so right now we've got a total of 5 scenarios, and we're ready to proceed to the questions. Okay, question 13. Which one of the following is a possible assignment of riders to bicycles with the riders for each bicycle listed in the order in which they test the bicycles? So we're dealing with a list question, and basically we want to go through all of the rules and apply them to each answer choice. And when an answer choice breaks the rule, we eliminate the answer choice. The last answer choice standing is obviously the correct answer to the question. So the first rule is R cannot occur with F. And if you look at A, R is actually occurring with F. So A is out, and we're looking at B through E. The second rule is Y cannot occur with J. If you look at D, Y is occurring with J, so D is out, so we're looking at now B, C, and E. The third rule is T must occur with H, either on day 1 or day 2. And if you look at B, T is not occurring with H, so B is out, and we're looking at just C and E now. And the last rule is Y1 and S2 must be the same bicycle. And if you look at E, Y goes with F on day 1 and S does not, so E is out. As such, C is the correct answer to the question. Okay, 14, if T tests G on the second day, then which one of the following must be true? All right, so we just take a look at this. We could have T testing G in this scenario right here. Okay, and let's just go down. We don't have T testing G anywhere else. So what we need to do is we actually need to make a scenario with what we have. And we'll actually place T with G in the second day, and then what happens is Y cannot occur here, so we have to have R here and then Y here. So it's the confining characteristic of this question that enables us to wholly solve this scenario. So let's take a look. So which one of the following must be true? A, R tests H on the first day. That cannot be true. It has to be T. Let's look at B, R tests J on the first day. That cannot be true. R must test G. C, T tests H on the second day. Y must test H on the second day, so that cannot be true. D, T tests J on the first day, and that must be S, so again, that cannot be true. And then lastly, E, Y tests H on the second day. Absolutely, that must be true. That's the answer to the question. The answer to the question is E. 15. Any of the following could be true except. Could be true except basically means cannot be true. A, R tests J on the first day. So let's just take a look. Well, in our second scenario, R is actually testing J on the first day. Therefore, that could be true. As such, it's not the answer to the question because we're looking for what cannot be true. B, R tests J on the second day. So let's just go through our scenarios here. Right here it occurs. In the fourth scenario, R is testing J on the second day. Because that could be true, that is not the answer to the question because we're looking for what cannot be true. C, S tests H on the first day. Right here in this scenario, S can occur right here. So that could be true. As such, it is not the answer to the question because we're looking for what cannot be true. D, Y tests H on the first day. So here is H. It can occur here, cannot here. Y is occurring here, and it cannot occur here. So D is the correct answer to the question. It cannot be true that Y tests H on the first day. Let's look at E. Y tests H on the second day. It could happen right here. So therefore, that could be true. As such, it's not the correct answer to the question. We're looking for what cannot be true. So we've proven that D is the correct answer to the question. Okay, let's look at 16. Which one of the following cannot be true? A, R tests G on the second day. So it could not happen here because R is there. We can't have the vertical, but it could happen in the second scenario. R could test G on the second day. Therefore, that is not the answer to the question because it could be true. Again, we're looking for what cannot be true. B, S tests F on the first day. We'll just go through. In the third scenario, S could test F on the first day. Therefore, that could be true, and it is not the answer to the question because, again, we're looking for what cannot be true. C, T tests F on the second day. So here we have S, S, Y, S, Y. That cannot be true. Therefore, that is the answer to the question. Again, C is the correct answer to the question. Let's look at D, though. R tests H on the first day. It cannot happen there, but it could happen here and here, so that could be true. As such, it's not the answer to the question. And then E, Y tests F on the second day. It could happen in this third scenario, therefore it's not the answer to the question. Again, we're looking for what cannot be true, and we've proven that C is the correct answer to the question. Let's look at 17. If T tests J on the first day, which one of the following could be true? It cannot happen in these first three. It could happen here, right here in these two scenarios. I'm going to go ahead and make these out just so you can see them. So in this particular example, we have T testing J, and we actually have, let's do it like this, T testing J here. Okay, so we're left with R and S, so we'll just make an option. Okay, so again, if you were taking the test, you would write it down here. I just want to keep this big so everybody can see it. So I've created, from the confining characteristic of the question, I've solved everything that can happen in this question. So which one of the following could be true? R test G on the second day. That cannot be true. It has to be Y or S. B, S tests H on the first day. Absolutely, it could happen here. S could test H on the first day. As such, that's the correct answer to the question. Let's look at C, though. Y tests H on the second day. That cannot be true. It has to be T. Let's look at D. S is one of the testers for J. Well, no, it can't be. It has to be T and R. Okay? And then E. T is one of the testers for G. Well, it has to either be RS and Y or YS. So we've proven again that B is the correct answer to this question. Let me go ahead and erase this for the last question. Okay, which one of the following cannot be true? Both R and S test J. Okay, well, it could happen here in this scenario. We could have S right here. Therefore, because it could be true, it is not the answer to the question, because for some reason they're very hardcore on this logic game about what cannot be true. That could be true, so it's not the answer to the question. Let's look at B. R and T test J. Same thing right here. You could have T here. Just some insight. When you have an open scenario like this and they're asking what cannot be true, it's always good to reflect on this particular one because it has the most flexibility. C, both R and Y test G. That could happen right here. So A, B, and C were all just eliminated from this. Because this thing is so open-ended, it proved that 3 of the answer choices could be true. Again, they're asking for what cannot be true, so they cannot be the answer. Let's look at D. S and T test for G. Well, there's a Y here. That's not an S or T. There's a Y and an S, so that's not an S and T. S and Y. SR or SY, so that cannot be. And then here is an R. That can't be an S or T. Therefore, D is the correct answer to the question because that cannot be true. And then lastly, just to flesh it out, both T and Y test for F. Right here it could happen. So we know for a fact that D is the correct answer to the question. Okay, that concludes LSAT Logic Game 3, Prep Test 64, October of 2011. Thanks.